Thanks for inviting me. So, first, a disclaimer, I'm not a security person. I'm a networking engineer who was stupid enough to stumble into the virtualization mess. And then it got interesting. So I said, well, yeah, sure, let's try this. And one of the things that happened in the virtualization mess is that they introduced firewalls into that mess. And what I'll do today is I will tell you from the architectural perspective what the options are. So I will not go into products, because he only gave me an hour. I will not go deep into detail, so I will just tell you what the broad landscape of the virtual firewall product is, and what different people are doing, because a lot of people are experimenting with different ideas. If you want to know more details, I'll be here for the next 2 days, and I can spend hours discussing things, as long as you don't ask me whether this is more secure than physical firewall or not, because that turns into a religious argument. OK, so just to mention that I'm doing a lot of other similar things, so if anyone is interested in more virtualization stuff, these are all the things I do. So firewalls, as we knew them in the past, they used to be easy. It was either packet filters or stateful firewalls. And then people discovered that this is like basic hygiene. This is like washing hands, because 90% of the attacks happen over here. Things like SQL injection and who knows what else. If you read any threat reports, everyone is telling you 90+% of the bad stuff happens at layer 7. And here we are protecting things at layer 3 and 4. So it's really like washing hands. You have to have it for good reasons, because sometimes you just might be vulnerable on layer 3 and 4. But these things will not protect you against the really stupid stuff like SQL injections. So those of you who are familiar with that American comic, XKCD, you probably know about Little Bobby Tables. The guy who named his child so that the name triggered a SQL injection.
Actually, we have people signing up at Troopers trying this, putting in...
and it doesn't work. Too bad.
Ending quote, or one equals one in the company name or so.
OK. And then the last one that we can discuss offline is, are load balancers firewalls or not? Because actually, they provide some functionality over here, and they provide some functionality over here. So you could misuse them as firewalls if you wish. But let's not go there. The other thing that is an endless debate is, should I have a routed firewall with inside and outside subnets, or should I have a bridged firewall, which is like a bump in the wire? And it really depends on what you're trying to do. So both have their uses. For example, here you typically can only have 2 interfaces, at least in most implementations. I'm positive there is a vendor out there that has a bridged firewall with 10 interfaces. I'm positive there is. And the other thing to keep in mind is that anyone producing anything these days also has a virtual something. So it started with firewalls a decade ago, probably. People were upset that you are paying tens of thousands of dollars or euros for a box that has 3 interfaces, inside, outside, and DMZ, or sometimes even 2. So first they wanted to have more interfaces. And then they figured out that, well, actually, managing 20 security zones with all different firewall rules on the same box is a nightmare. And it is. So someone came up with this great idea. What if I split this box into multiple boxes? And these are not the virtual firewalls we are looking for. These are the virtual contexts on physical boxes. It's an old, boring concept. Keep in mind that usually they tell you how these things are totally separate They still share the resources like CPU and interfaces and memory, and they share the same code. So in theory, they are isolated instances. In practice, there is a lot of shared state. Keep that in mind before you ask me the question about virtual firewalls running on top of a hypervisor. There's a lot of shared state here that no one wants to talk about. So if we compare virtual contexts on physical firewalls with virtual firewalls, and let's say for the moment that a virtual firewall is a VM with two interfaces running on whatever hypervisor of your choice. We'll see later on that there are other things, and I'll go there, but for the moment, let's say a virtual firewall is a virtual machine with two interfaces. So the first thing is that now people are experimenting with all sorts of transport technologies that should get us beyond 4,000 VLANs. Now, is anyone in the room that needs more than 4,000 VLANs? Okay. Anyone that is a cloud provider needs them. Because hopefully you have more than a few hundred customers, otherwise things don't work out financially, unless you have customers like BMW and Mercedes, in which case it's okay. And each customer usually wants to have a few subnets for security reasons. So you need a few VLANs per customer times the number of customers. 4,000 is a very small number. So people are experimenting with all sorts of different transport technologies. And those transport technologies are usually supported in the hypervisor because, that's what the hypervisor vendors live on. But of course, they're not supported by the physical appliances. So you want to implement something like VXLAN from VMware or NVGRE from Microsoft or STT from Nicira, now VMware, or GRE between Zen server boxes. Those things can't be filtered with a regular firewall because your firewall vendor doesn't care. On the other hand, if you have a virtual machine that sits on top of these thingies, that virtual machine doesn't know that you're using VLANs or VXLAN or what have you. So you're totally independent from the transport technology. Okay? Now VXLAN is getting supported by people like F5 and Brocade and now Arista. And NVGRE is supposedly supported by F5, and Dell has announced something but hasn't shipped yet. So things are getting better, but in principle, these things will evolve, and the physical firewalls will always be like one generation behind the leading edge. The other thing is the configuration management. With a virtual machine that's a firewall, it has the configuration which is stored on the virtual disk. It's very easy to take the virtual machine, well, you shut it down, you take the virtual disk, you move it to some different place, and you restart the virtual machine, and you're back in business. Disaster recovery, like this. Try to do that with physical firewalls. Mission impossible. Okay? Workload mobility. You want to move a whole application stack from data center A to data center B. It could be for migration purposes, it could be for disaster avoidance purposes, it could be for disaster recovery purposes, whatever. You have to move the whole stack. Okay? With virtual firewalls, you shut everything down, including the firewalls, you move everything, you start it. You're done. Try doing that with physical firewalls. Oh, there are people out there that are saying, okay, we have these firewall clusters, every vendor supports them. Like Cisco supports firewall clusters, Checkpoint does, Juniper does, everyone does it. So let's just put one member of the cluster here and another member of the cluster there, and the configuration will sync automatically. Okay. Please don't even mention this to me. Because some people don't get it, but in networking, actually, sometimes both links might fail. I mean, that's a surprise to most people out there, but sometimes networks fail. And you have a split brain cluster, each firewall going on its own, doing some crazy stuff. Trust me, you don't want to be in that data center at that time. I mean, I've seen it once, it wasn't pretty. With virtual firewalls, it's a very obvious thing to do. Shut down everything here, you move it over, you start it, you get the firewall. So, the good news, we are independent from the transport network. We can use VLANs, we can use whatever else we wish. We have great configuration management because, oh, one other thing about the configuration management. If you have multi-tenant environment, and it could be public cloud or private cloud, every tenant can manage his own firewall. Okay? You want to do your own stuff? Be my guest. Here's your virtual firewall, play with it. Oh, you were hacked. Too bad. It was yours. So, we can easily offload the responsibility if people are willing to take it over. Great stuff. So, now for some bad news. Well, performance. But you'll see that it's not as bad as it seems. Hardware is not a problem. Broken implementations are. And of course, there are attacks on the hypervisors. And if you have a multi-tenant environment, there's always the noisy neighbor problem. So someone is attacking your neighbor, and because his firewall is sitting on the same physical server as your firewall is affected. Because he is defending himself and using up shared resources. And there's not much you can do about that. Attacks on the hypervisors, well, there have been known exploits. I told you I'm not a security person. I haven't heard of anyone actually doing that in the wild. So the exploits that I've seen were primarily hypothetical, although doable. So my sarcastic take on it is, how secure does your auditor want you to be? So, honestly, if you think that running inside and outside security zone on the same switch is a bad idea, then you don't want to use virtual firewalls. If you think that running inside and outside in two VLANs on the same physical switch is okay, then you've already crossed one of the boundaries. If you think that it's okay, it's totally inappropriate to run inside and outside virtual machines on the same cluster, then maybe you don't want to have virtual firewalls. If, on the other hand, you think that it is okay to run a public web server and an inside application server on the same vSphere cluster, then you have no argument against virtual firewalls, because you've already breached the boundaries. Okay? So it depends on where you are in the whole risk span. You want to be totally protected, use dedicated infrastructure for every security zone. You don't care that much, well, maybe virtual firewalls are okay for you. The final word, if you're a financial organization or if you need PCI compliance, is with your auditor. Whatever you persuade your auditor is okay, is okay. Now for some real stuff. So, in an ideal world, when you virtualize your applications, you would also fix all the mistakes from the last 20 years. Has anyone ever seen that happening? Okay, thought so. So, your users, which in this case would be application teams, still want to have the same old thing they had previously. So an outside load balancer and a firewall, web servers, load balancer and a firewall, app servers, load balancer and a firewall, DB servers, load balancer and a firewall, application, well, authentication servers, and so on and so on and so on. Okay? So no one wants to get away from the existing structure. They want to have the same functionality, only virtual, and cheaper, of course. Well, they don't care about virtual, they care about cheaper. So they want to use the virtual machines like physical hosts, but of course they want to deploy and move them at will. Within a data center, between data centers, that makes perfect sense. Whatever, they just want to move them. And then I see consultants throwing business agility at me, and I get sick. So they want to build virtual LANs, and they want to retain the existing security paradigm, so firewalls between subnets. On the other hand, on the hypervisor side, we need to decouple physical from virtual, otherwise you can't move the VMs if you don't decouple. And somehow you have to enable the inter-VM traffic and provide inter-VM isolation. So, will these boxes be physical or virtual? In traditional data centers, you virtualize the servers, but you keep the physical load balancers and firewalls. That's how we've been doing things for the last 10 years. There is now an option that you could virtualize these middle boxes as well. And there are 4 architectural things you can do. VM-based appliances, which is the same as physical box, only in a VM form factor, or NIC-level firewalls, which is actually a firewall sitting just in front of the VM. I'll go through all this in details. And then there is service insertion and service chaining, and I'll tell you what that is. But let's start with the easy part first. So, of course, every vendor selling you firewalls and load balancers is telling you how they have secret sauce inside, how their box is the only one that can do whatever it is they're doing, because they have this secret hardware inside. In many cases, it turns out that the secret hardware is actually a NIC that can do TCP offload. Because no one is willing to invest in hardware-assisted firewalling or load balancing because hardware is expensive. And it turns out that you can do the same things in software at reasonable speeds. Now, the last company that I know of, well, there are 2, that had hardware-assisted load balancing wasn't able to support V6 for years until their latest model that is now almost discontinued. It's a 5-letter company I will not mention. With a discontinued load balancer. So most of these things are already software-based anyway. And some vendors are more open about that than the others. And it really depends on whether your sales team can sell software. Some vendors are still selling the hardware because that's how their sales organization is structured. But they could easily run the same thing on third-party hardware. Okay? So you have all sorts of firewalls, like Vayata, which is now Brocade, so now they look honorable. The product is still the same, but now there's a big name behind it. F5 has a load balancer that is VM appliance. A10 has a load balancer that is available as VM appliance. Riverbed has a load balancer. And there are all sorts of startups. LineRate, for example, was a great startup, and they just got bought by F5. On the firewall front, I think there are a few firewall vendors that also do firewall in a VM. I think Checkpoint has something. Not sure about that. So anyway, the beauty is that, of course, this will work with all network virtualization technologies. The hard part is the performance. Because every packet has to arrive into the hypervisor, goes through the hypervisor kernel, goes back into user land, which is actually the kernel of the virtual machine, is processed by the kernel of the virtual machine, thrown maybe into the VM user land, and then all the way back. And of course, that takes quite a few CPU cycles. So if you really don't care about performance and you do like IP tables with fancy GUI in front of it, you get approximately 1 gigabit on one virtual CPU. This is what VMware claims for vShield Edge, which is firewall/load balancer as a VM appliance. If you're a bit smarter about what you do and you fix the TCP stack in your VM, then A10 can get to 8 gig on that same one core, just by removing the Linux TCP stack from the picture. Linux TCP stack is awful. If you remove the Linux TCP stack from a VM, you get to up to 8 gig per core, which is more than enough for most people. If you remove the hypervisor and the Linux TCP stack from the picture, you get 40 to 60 gig through a single Xeon-based server. So it usually stops at around 40 gig, but not because the CPU would be overloaded, but because the other components of the server don't cope with the load anymore. Like you have memory contention problems and things like that. So there were people who pushed this much through a single x86 box, and CPU was not at 100%. So hardware is not a problem. Linux TCP stack that every single appliance is using and hypervisor stack is a problem. Now, there is a company in France that does its own TCP stack for Linux. That same thing is offered as Intel Data Path Development Kit, DPDK. So that's the company that actually developed the software for Intel. And they told me that if they replaced the Linux TCP stack with their own stack in a VM and bound the interfaces of that VM straight to the hardware, so hypervisor bypass, they got 20 gig out of that single CPU. Okay? So the performance will go up as people figure out how to kick away these two roadblocks. On the other hand, in traditional data center, where you have firewalls and load balancers sitting at the outside, and then you have the switches, and then you have the servers, you know how the traffic will flow. If you virtualize things and you allow them to move around, then you think that the traffic is flowing like this, which looks OK, right? But in reality, the traffic is going across the network, entering a server, going out, entering another server, going out, going here, and so on. So you see, all of a sudden, you get all this spaghetti of traffic going over the same core, network core many times. Now, this is a real problem in traditional data centers that were way oversubscribed. If you build a new data center and you know what you're doing, and you're using something called class architecture, which was, by the way, invented more than 50 years ago for voice switches, you can build a huge data center fabric with what people call equidistant endpoints. So any 2 points in the data center have the same bandwidth available between them. And once you have that, you actually don't care where the firewall is sitting, because any 2 endpoints are equal. So you don't really care where you place the VM with the firewall. Okay? And now let's move on to a more interesting concept, which is NIC firewalls. So these are the firewalls that actually sit in front of individual VMs. So in traditional virtualization environment, you would have different virtual machines in different security zones, and they would be in different VLANs. And every hypervisor has a layer 2 switch, and this switch would preserve VLAN separation, and then you would have a trunk port going out to the physical switch, and multiple VLANs going to the physical firewall. So the traffic would go from blue over blue VLAN to the firewall, and then back over the red VLAN to the red VM. Okay? This is how we've been doing things for the last 15 years. Now, imagine that instead of all this, you put small firewalls in front of every virtual machine. So you don't need any VLANs anymore, hypothetically, because every virtual machine is protected with its own small, tiny firewall. And it could be either a packet filter or a full stateful firewall. And usually, these things are managed from a central management system, so that obviously you can't manage each one of them individually. That wouldn't scale. Usually, you have some management console where you select the VM, and then you apply the rules to the VM, or you apply the rules to the whole data center, or the port group, or what have you. This looks great, right? It does change your perspective completely. In the old world that we all understand, a security zone was a VLAN, was an IP subnet. And if you run out of VLANs, you can throw this new stuff in. But still, things in the same security zone would be in the same subnet, and that would be in the same VLAN. And by the way, these firewalls would become choke points, because everything between two security zones has to go through that central box. Physical or virtual, doesn't matter. Now, imagine a brave new world where you have one subnet and a firewall in front of every virtual machine. Hypothetically, these two pictures are identical. Even better, here, the VM is protected against other VMs in the same subnet, which is not the case here. Someone breaks into one machine in the database subnet. Usually, he can own all the other machines in the same subnet, because they're not protected, because everyone thinks that the firewall should protect them. So we can go from here to here. Hypothetically, it's the same thing. The real question is psychological. Are you willing to make that shift in paradigm? Are you willing to go from here to here? And going back to my previous remark, is your auditor willing to go with you? I don't know. On the other hand, if you get here, then because the firewall rules are attached to individual virtual machines and they travel with the virtual machines as you move them across the data center, this thing is, in principle, infinitely scalable. Because you just add a few CPU cycles to every virtual machine and you're done. As you scale your compute cluster, your firewall capacity automatically expands. And there is no more tromboning through the physical or virtual firewall. Traffic flows optimally from point A to point B. And the performance hit is always on the virtual NIC, not on some middle box somewhere in the middle. But going from what we know to this new thing may be scary for most people. Now for a few solutions that are out there in the wild. VMware has something called VMsafe Network API, which is a hook that allows you to insert whatever you wish in front of the virtual machine NIC. It's actually a hook in the driver for the virtual machine NIC. And different people are using that hook for different things, usually for virtual firewalling, although HP has a really interesting other thing that I'll also show later on. And there are two products that I think I will mention. VMware has its own firewall, and Juniper has something which is, I think, Altor acquisition, if I remember the names correctly. On the Linux side, you have the usual stuff like, because on Xen or KVM, you actually have access to the kernel that runs the virtualization. So you could implement IP tables or IPsec tables or EB tables down there, which you cannot do with VMware because on vSphere you don't have access to that part of the operating system. And there is now, even in mainstream Linux, but in Xen it was available for a long time, Open vSwitch, which is an enhanced bridge with open flow rules, so you can program it from the outside. And Citrix has Xen something manager that actually uses OpenFlow to install packet filters in front of virtual machine NICs. And Nicira is also using Open vSwitch. That's the new acquisition by VMware. And there's another startup that's doing all sorts of fancy stuff. Hyper-V was particularly bad till Hyper-V 3.0. And then they made an amazing step forward. I mean, compared to what other people are doing, and compared to what Microsoft did going from here to there, when I looked at that, it was like, wow. So they were really bad previously. And now they have a totally extensible switch where you can install your own extensions for capturing, for filtering, and even for forwarding. And the whole thing is totally documented on the web. Not like VMware where you have to sign whatever agreements with them to get access to this API. Everything you need to write a filtering extension for Hyper-V is right on Microsoft's website, including sample code. You just go and do it. And there is a company that did it, so there is already a virtual firewall for Hyper-V. Now, the obvious questions you should ask when a vendor comes around telling you how great their product is it stateless or stateful? So what happens with return traffic? And some people actually have true stateful firewalls like you would expect a firewall to be. And some people just say, oh, well, you know, actually it's a packet filter, but we also install the reverse filter in the opposite direction. Yeah, that's safe. It depends on your level of risk. So that's the first thing you have to ask. The second one, very important. Are you doing filtering in kernel or in a VM? That's a performance question. No, let me see. No, I don't have that slide. VMware has the vShield app, which actually does all the filtering in a VM. The maximum you can push through that thing is 3 to 4 gig per server, which is okay, right? Maybe it's not okay for some high volume environment like video streaming, but for regular use case, it's okay. Juniper, with its virtual gateway, does all the filtering in the kernel. So they can push 30 gig through that same box, firewalled. And if you really want to know the details, of course, Juniper has a nice white paper on their website documenting all the measurements they did against a certain competitor and how their product was better than the other. The next question to ask, do I need a per hypervisor VM to control this stuff? In VMware environment, because of the way their API is structured, you actually need an extra VM on every hypervisor host to control and manage the virtual firewalls. With Hyper-V, you don't need that. With Linux, with OpenFlow controller, you don't need that. And of course, the obvious question then is, what happens if that VM fails? And it depends really on where you do the filtering. So if you do the filtering in kernel, then who cares if the VM fails? Yeah, I will not be able to download the new rules. Okay. But still, my existing VMs are protected. If you're doing the filtering in the VM and that VM fails, what do you think happens? Well, there are two options. Well, initially, all the VMs would be isolated from the rest of the network, which is actually the proper response. Now, with vSphere 5. something, you can configure whether it's fail open or fail close. Your choice. But remember, if a vendor is using a VM to implement the virtual firewalls, if that VM fails, you're in trouble one way or the other. So this is actually the structure that VMware is using for VMsafe Network API. So you have the kernel module that implements whatever functionality you want to implement. And then you have the VM that has to run on every host where you want this virtual firewall or what have you. And there is a hidden vSwitch between the two. That hidden vSwitch is used for the control VM to program the kernel module. And because of that hidden vSwitch, that obviously shouldn't be accessible from the outside, or it wouldn't be secure, because of that hidden vSwitch, you have the problem of having a control VM running on every host. Because if the control VM is not there, well, who will access this switch? Okay? And remember that this kernel module is actually sitting not in the switch, but it's sitting between the switch and the VM. Okay? So the virtual switch is still doing whatever it's doing. You can't control that. You can only control what gets in and out of a particular VM. Okay. So as I said, vShield app is one of them, virtual gateway from Juniper, and well, tipping point I'll mention later on. Based on whether they do filtering here or here, there is like a 10-time difference in performance. Then some other vendors came along saying, well, you know, that's cool. Oh, by the way, none of these products has a multi-tenant configuration interface yet. So all of them assume that you have one security administrator for the whole data center, and he is configuring whatever he is configuring. If I remember correctly, and now I'm guessing, vShield zone/app can do different rules per port group, and virtual gateway can do different rules per VM. But check the manuals. Things change. So Cisco did a totally different thing, as expected. So they said, we don't want to have anything sitting in the host. So we want to have something on the outside, so like a firewall here. And well, because we own the switch here, this has to be Nexus 1000B from Cisco, not the vSwitch from VMware. We can now redirect the traffic. So we will have like these redirectors here in front of VMs. So when the traffic comes in, this thing will send the traffic out to an external firewall. That firewall will do whatever it does and send the traffic back in, because now this is coming from the firewall, it goes straight to the VM. Okay? Sort of makes sense, sort of doesn't make sense. It really depends on what you're trying to do. So on one hand, you are shuffling the traffic back and forth to the outside firewall. So it does look like a VM appliance. On the other hand, it is inserted in front of a VM NIC. So it appears as a bump in the wire. It's not a routed firewall. Most appliances are routed firewalls. And they added an extra twist. When this firewall figures out that the flow is OK, it downloads the 5-tuple source destination IP address protocol port numbers into the switching module in the kernel, and then the rest of the session is not redirected to the firewall anymore. So initial packets go to the external firewall. They are inspected. When the firewall says this is OK, then the shortcut is installed in the kernel module, and the rest of the session is forwarded just through the kernel module. So it's not as bad as it looks on this slide. Okay? On the other hand, what HP has with tipping point vController is actually as bad as it looked on the previous slide. So they have a great IDS product. So people tell me I don't know anything about security. And they wanted to repurpose that great product in virtual environments. So what they actually do is they use this VMsafe API to install the kernel module in vSphere hosts. And this kernel module redirects the traffic to the external IDS IPS and then back to the VM. So their selling point is that, it's usually hard in virtualized environment to figure out where the traffic is flowing and to ensure that the traffic flows by the IPS IDS as it should. But with our plugin, you can ensure that the traffic does go by the required IPS IDS. Which in some environment probably makes sense. The only, in double quotes, problem is that these external boxes, aren't exactly known for very high speeds. The high-end box that I've seen was 10 gig. For the whole data center, maybe not enough. And they tend to be expensive. So in some very special environments where you actually have to inspect all the traffic going in and out of a VM, this might be an option. In more regular mainstream environments, you maybe don't need that level of inspection. But your auditor is the one to say yes or no. Okay? And this is actually how the structure of Virtual Security Gateway, which is the Cisco's product name for this thing. So you have to have the Nexus 1000V in the vSphere host. Without that, it doesn't work because they're using their own service insertion technology. By the way, the thing redirecting the traffic from the hypervisor to some external thing and back is called service insertion. Okay? It's a fancy marketing name for redirection. So you have the switching element here, and then you need the control plane, the VSM, that actually controls this switch. And then you need the firewalls that will receive the traffic and say this is OK or this is not OK. The beauty of this architecture is that on every single port group, which is like the VLAN, if you wish. It's not exactly VLAN, but you know what I mean. So on every single port group, or even on every single port, which would be VMNIC, you could specify who the firewall is. So you could have one firewall for this set of VMs and a different firewall for another set of VMs. And even if the two sets of VMs use the same firewall, you can always attach an extra attribute to tell the firewall which context to use for this particular VM. So you can deploy this in two scenarios. Either you have one VSG per tenant. So every single tenant would have his own firewall, and he can do whatever he wishes with his firewall. breaking it, misconfiguring it, whatever it is. Or you have one context per tenant, and then you will have different sets of rules for different tenants or different security zones or what have you. So from the flexibility perspective, this gives you way more options than the things I've been showing on the previous slides. But of course, it comes with an extra performance hit because you have to go out and back. And then Cisco came out with a firewall appliance, the ASA in VM form factor. And of course, they figured out that they have a problem. Because now you have the layer 3 firewall, and you have the NIC level firewall. And if you use the traditional approach, like NIC level firewall is implemented in the hypervisor, and this external firewall is implemented in a VM, you don't have a problem. But if you're using service insertion like Cisco is using, then you do have a problem. Because imagine that the traffic comes from the outside. It has to go to the external, the routed firewall first. OK? You already see what's going on. So it has to go to the routed firewall. Because we are in different subnets, things have to go through that firewall. And then it goes to the destination IP address based on the destination MAC address. Hey, not so fast. There's an interceptor here that sends the traffic to the bump in the wire firewall. And then the bump in the wire firewall looks at the traffic and says, well, it's OK. Yes, it can pass, and send it back to the VM. So the traffic is actually traversing the data center one time too many. OK? And what Cisco did was that they actually, in their VPath technology, they have something called service chaining. So when things like Nexus 1000V and VSG and VASA figure out that actually we are sending traffic back and forth unnecessarily, VASA would get a shortcut saying, hey, don't go to the hypervisor because the thing has to go through VSG anyway. Okay? So because all the three components are from the same vendor, because there is no standard protocol to do it, they can install the shortcut here so that the traffic goes through VSG first, and then it arrives to the hypervisor, and it has that extra header saying this came from VSG, so it's OK. And so it goes to the VM. As far as I understand, and I may be wrong, you can combine ASA 1000V Cloud Firewall, which is the official name for ASA in VM form factor, with VSG. Obviously, there are other things you may be able to do today. I don't know. But you will definitely be able to do in the future, like combining these two with a WAN accelerator product. They have WAS in an appliance. And WAS is also a bump in the wire. So it is technically possible to chain all three together. So the traffic goes through the routed firewall, and then through the WAN accelerator, and then through the bump in the wire NIC firewall, and then arrives to the VM. So that's a potential option. OK, and now for some quick conclusions. VM appliances are, for more or less all purposes, identical to physical devices. Usually, they also have the same feature set, apart from a certain 5-letter company that I happened to be mentioning on the previous slide, which had IPv6 support in their physical firewall for a decade, and still doesn't have IPv6 support in their virtual firewall. Because no one is using IPv6 in the data center, right? So VM appliances are almost equivalent in most cases to the physical devices. If you are concerned about security and noisy tenants and so on, maybe as an interim step, you could create a separate cluster of servers and deploy only firewall appliances. And then you would get something that would be almost identical to the virtual contexts on the physical firewalls. Not exactly identical, but as close as you can get. And all these things obviously generate extra traffic across the data center, what marketing people call east-west traffic, because it's moving this way, not that way. And if that's the case, then it's best if you have the data center fabric that is not too oversubscribed. On the other hand, NIC level firewalls, they do give linear performance. So as you add more VMs, each VM has a firewall attached, and that firewall is just eating a few CPU cycles. Well, a few is like 10%. So it's not like, but it depends on your workload. So the more CPU intensive the workload is, the less the firewall is using. The more I/O intensive the workload is, the more CPU cycles the firewall is using. That's obvious. But you have to be ready to go from the old world to the new world. And service insertion and chaining, I really like Cisco's architecture because of its flexibility. It allows me to deploy either centralized firewalls or a firewall per application or a multi-tenant environment. But on the other hand, there is some performance trade-off. OK, and this is just for those of you that will. This is a long list of blogs and podcasts that you should really read if you're interested in these topics. And this is for reference purposes when you read this on the web. And while some people will write this down, if you can read it, I'm here for any questions you might have.
Yeah, thanks, Ivan. Great presentation. I had no interest in that one, just answered some of the questions I had personally. I'm happy it did. What about the sharing questions right now?
Maybe one question regarding not technology, but you said it's a change of paradigm. We are going through this discussions in SSD data centers as well, so the guys, the network, don't tend to go to this new paradigm because they want to keep their stuff separate, they want to keep their things separate. And as soon as we start talking about NIC firewalls, they say, okay, that's the VMware guys, they need to do it there. What is your experience here?
Well, probably as bad as yours. Now, honestly, we pushed this old organization in silos to an extreme. And it's hurting us more and more as we go toward these things. Things usually work only if different teams manage to start talking to each other and eventually merge. If you can't do that, then it's best to stay with physical firewalls and physical servers. The usual problem is on layers 8 and above. And the problem is, as you probably, well, I'm sure you all know, is that everyone is trying to shift as much responsibility away from him as possible. So in an ideal world, you know, the application teams would be responsible for their own security. And the security team would be there only to check for the compliance. And in that world, we wouldn't be having this discussion. Okay? The move from physical to virtual firewalls, particular case, might work if the two teams actually sit down and figure out who will be doing what. And from the psychological standpoint, if that's the situation you're facing, maybe Cisco's Nexus 1000V plus VSG might be a good political option, because it is so similar in concept and a split of responsibilities and operations as what they had before. I'm not saying it's the best technical alternative. I'm just saying that it's the closest to what these people were used to till now. Because with Nexus 1000V, you have a CLI that's identical to the physical Nexus switches. And with VSG, you have some sort of CLI that reminds some people of how firewalls were configured, although it's a totally different product. And you retain that split of responsibilities. It is possible to do something similar with, let's say, vShield app, and I think definitely with Virtual Gateway from Juniper. But it is within, it has to be done with user roles within the same framework. Yeah, and there, if the teams don't talk to each other, you have a problem anyway. But as I said, in the ideal world, the networking, server, and virtualization teams and security team would get together and push all the responsibility back to where it belongs, to the application teams.